Good morning, class. So for homework, you had exercise 4. It was numbers 2 to 6, 2 to 5. It was numbers 2 to 5 on page 263. Correct? Alright. So as promised, I'm going to do each and every one, if I can. Which exercise is this? Exercise 4. Page 263. Thank you. So we are told that in the diagram ABCD is a parallelogram. Without reading any further, what does that mean? If ABCD is a parallelogram. Sorry? DC is parallel to AB. Yes? So that's one. There's 4 properties. Angle A is equal to angle C. The whole of angle D is equal to the whole of angle B. Opposite sides are equal, yes? And one that is not applicable here, diagonals bisect each other. Not so. So those are the 4 properties of a parallelogram. People, you're going to hear me saying all the properties all the time. I want you to take note of it. So when I go through those things, you're supposed to be saying it in your mind already. Okay? Because later on when we do your analytical geometry, or even your geometry, Euclidean geometry, we need to know those properties. Okay? What else are we told? We are told that BE is equal to BC. So if those are equal, what do we know? E2 is equal to angle C. Why? Angles opposite equal sides. Then we are told that BD is equal to BC. Sorry, AB. I'm reading it wrong. I'm looking here. Okay? So what can we conclude then? The D1 is equal to angle A. Not so? Angle A is X. Prove that. So how do we start off? We start off by naming the triangle. In triangle ABD and triangle CB. So we are required to prove that angle ADB, ABD is similar to triangle CBE. So to prove similarity, what we do? We can do one of 2 things. We either prove that the angles are equiangular, which means to say all 3 angles are equal, or we prove that the sides are in proportion, but we don't have no lengths here. But what can we say already about these 2 triangles? We know that angle A is equal to angle C. Not so? Then we know that D1 is the same as X, not so? Angles opposite equal sides. E2, the same as C, which is X, angles opposite equal sides. Which result in angle D1 being equal to angle E2, which is equal to angle X. Not so? So there we have a second angle. Which angle are we left with? We are left with B1 and B3. So B1 is equal to B3, why? The third angle of a triangle. Okay? Yes, Michael?
Would it be wrong if I say B1 equals to B3 alternatively?
B1 is equal to
D1.
D1. Let's find D1. D1 is equal to
B3.
B3. Okay. We're saying that a line is parallel to that line, not so?
Yes.
Let's see here. Can you see that? This angle here is actually equal to that whole angle. Make sense? Could I have said it's alternate? No. Okay. Let's take it off again. No. Let's keep the information that we have. Okay. Okay. So let's write this out neatly. Firstly, we see that angle A is equal to angle C. So angle A is equal to angle C. Why? Why is that the case? Angles, or opposite angles of cyclic chord. Not cyclic chord, sorry. Parallelogram. Opposite angles of parallelogram are equal. Okay, we can put equal there if you want. Okay, but here already we're saying they are equal. But if you're one of those girls that want to, write too much or enough, no word. Align the board quickly. Okay. What was I trying to take away? That's it. Alright. So that's the first thing. Then we said for the second angle we're going to prove is equal. We say that angle D1 is equal to xy. Angles opposite equal sides. Could I have said sides opposite equal angles here? No, you will lose the reason mark. Okay? You can't say that. So what else can we say? That angle E2 is also equal to xy. Angles opposite equal sides. So what can you conclude now? Therefore, D1 is equal to E2 is equal to x. Okay. So we got two angles that's already equal in this triangle. So therefore, the third one is going to be angle B1 is equal to B3, which is equal to x. No, not x. B1 is equal to B3. And the reason? It's going to be the third angle of triangle. Is that enough information to conclude similarity? Absolutely. We have three angles. So what in conclusion we can say therefore, I've got to pull this down here. What can we say at this point? Therefore, triangle ABT is similar to triangle CBE. And what's your reason there? Angle. Okay, it's very important that your order is in the right order. You see how angle A is with angle D, angle B is with angle B. Can you see that? The order is very important. Alright, you guys understand? Alright, so what I'm going to do is, I'm going to take this off here, so that we can keep the diagram in focus, okay? Okay, so let's look at B. In B, we are told we must prove, so we go. We know that it's going to be a distance question following a similarity question. And the similarity is going to come from these triangles here. So what do we say? AB over CB equals BD over BE equals AD over CE. Why? Because sides are in proportion, or you can say triangle ABD is similar to triangle CBE. Okay. But what do they want? They want AB is AB, BE is there. So it's going to be this that I'm going to work with. Here already I got two ratios. If I look at BD, yes, and BC, yes. Can you see that, people? So what do we do here? It's just a matter of cross multiplying. So therefore, AB times BE is equal to BD times CB or BC. Okay. You all understand? Any confusion? No? So let's look at C. So again, it's a distance question. So we say C, of course, is going to be AB over CB is equal to BD over BE and equals AD over C. Again, the two triangles are similar, okay? So don't take it off here because of the space. So if we look at what we have, or what we need BD, which is this here, AD, which is that, BE, which is that there, and CE, which is this here. Not so? So there is exactly what we have. Not so? Then we conclude therefore BD over BE is equal to AD over C. You guys understand? Do you guys understand? Any confusion? You guys get it right? Yes, okay. You guys talk to me, man. Feel like I'm going crazy. Mustn't be shy to ask a question, no? If I don't know how to answer, I will tell you, I'll get back to you, okay? And I won't forget, I will try and find the answer. Okay? This is exercise 4. On exercise 4, page 263, we're looking at number 3. Okay. So here we are told that in the diagram, EF is parallel to CGD. They didn't have to say that. They could have just said CD. Okay. If those are lines of parallel, what do we know? We know many things. What do we know? Come. We know that F1 is equal to angle D. Angle E1 is equal to angle C. Why? Both sides corresponding. What else do we know? F2 is parallel to is equal to G2. Why? Alternative. What else do we know with regards to F2? F2 plus G1 equals 180. Why? Coincidence. Okay? So all that comes to mind if those lines are parallel. The question says prove that. So how do we start off by prove that question? Oh, we also told that these lines are parallel. If those lines are parallel, then angle C is equal to angle G2. What else do we know? E1 is equal to? No, that is because those lines are parallel. Then E1 is C. But I'm specifically highlighting, the fact that these lines are parallel. Can you see? So we mentioned what you are saying, E1 and C. Okay. I don't think there's anything else of note at this point. So how do we start this off? We say in triangle. You go in triangle, BEF, and triangle FGD. You cannot say triangle BEF is, instead of saying and, you say similar. Okay, they will be you will penalize you immediately for that. Okay, so don't do that. You can rather leave it out instead of writing that similarity. Otherwise, you can say RTP or required to prove this. You can put the similarity. Alright, so if you're looking at BEF and triangle FGD. Right, so what can we say here? What can we say? E1 is equal to? E1 is equal to which angle? Equal to angle C. Not so? And angle C is equal to which angle? G2. So they already have one angle. Okay? We need another one. Sorry? F1 is equal to angle? What? F1 is equal to angle D. And our second angle. So what are we left with? Angle B and angle F3. They are equal Y. Third angle of triangle. Not so? So let's go. We're going to say we can start with F1 is equal to D. So angle F1 is equal to angle D because of corresponding angles with EF being parallel to CD. What else do we know? We say that E1 is equal to angle C. Why? Corresponding angles with because that corresponding angle is lying that way, okay, its EF has to be parallel to CD. So EF is parallel to CD. So this angle here is equal to that angle here. Then we're going to look at the corresponding angles lying that way. So this is again GF is parallel to BC. Okay, you must name the right lines of the parallel with the right angles in question. Okay. So we're saying that angle C is equal to angle G2. Why? Again, corresponding angles are equal, with BC being parallel to FG. So in conclusion, therefore, E1 has to be equal to angle G. Okay, you guys understand? And then thirdly, we can conclude that therefore, which is the other angle that we didn't speak about yet, F3 and angle B. So angle F3 is equal to angle B. Why? It's the third angle of a triangle. Do we have enough to conclude similarity? Yes. So therefore BEF, triangle BEF, is indeed similar to triangle FGD. Why? Angle. Okay. And you just check that the corresponding sides is indeed equal. So B with F3, which is right, angle E with angle G, which is right, and angle F of the triangle with angle D of this triangle, which is also correct. You guys understand? Something like this is already worth 4 marks. Okay? It comes in every exam from here onwards. Okay? Please make sure you understand. I'm going to take this off. Why? To keep the diagram in focus. Okay? Take it away. So that was the answer to A. So let's look at B. We said from a similarity question will come a distance question. So what can we say here? That BE over FG equals EF over GD equals BF over FD. You can say sides are in proportion. Sides in proportion. Okay. What do they want? They want DG, which we have there. FG, they have there. So this is what we work with. EF and BE. Yes. DG. So this one is on top. BE is at the bottom. Not so. EF and G is on its right place. Not so. This is a matter of replacing. So therefore, GD over FG is equal to EF over FG. Other 2 marks. Sorry? BE. You see, I would have lost one of the 2 marks. What's wrong with me? Okay, many things, no? BE. I was like, people, you guys understand? Any confusion here? As you can see, I'm taking my time with this here. I'm not rushing. Because why? Even taking my time, I'm making mistakes. Okay? But you guys don't make mistakes. No? You guys know better than that. Am I right? Oh my word. Then number 4. Got the question 4. Let's show this out. Right. So here we are told that, in number 4 we are told that PB is a tangent to a circle. PB is a tangent to a circle. So if this is a tangent, what do we know? B1 is equal to angle C. Why? Tan equals 0. Then we are told that PA is parallel to BC. So what do we know from here? B2 is equal to A1. Why? Alternate angles. The question in A says prove that is the case, similarity between these two triangles. So you got PAB and ABC, which is this one. So what are we still shorting? The third angle. But can we conclude that angle A2 is equal to angle P? Yes. Why? Third angle of the triangle. You see how easy it becomes now. Okay? And you do as I'm doing here, as I'm reading through it, I fill in the not inflammation, information. Okay. Right. So where do we start? We say in triangle PAB and triangle ABC. So PAB, what can we say? We say that A1 is equal to B2. So angle A1 is equal to B2. Why? We say these alternate angles with PA being parallel to BC. Then B1 is equal to angle C tan O theorem. A2 is equal to angle P. Why? The third angle of a triangle. Enough to conclude similarity. So therefore PAB, triangle PAB, is similar to triangle ABC. Why? Angle. You all okay with that? Any confusion? Or any you guys did it another way? Okay. Take this off again. Right. Now let's look at B. Definitely a distance question following a similarity question. So we can say that PA over AB is equal to AB over BC equals PB over AC. Why? Because triangle PAB is similar to triangle ABC. All sides are in proportion. So we say that PA and AB. But what do you notice? There's two ABs here. So it could be that one as well. So I can't decide yet. But it has an AB and a BC, so it has to be this. Not so? So what can I say at this point? That PA over AB is the same as PA is to AB, as AB is to BC. They have done exactly what they want. You guys understand? Let's go with C. AP is AP. BP. So there did you have two ratios. Can you see that, people? So we're going to say here that PA over AB is equal to PB over AC. Why? Sides are in proportion. Okay, sides in proportion. So just to look at what what they want. AP is on its right place, PB must come down, not so. Then AB goes on top, AC is on its right place. So therefore, PA over PB is equal to AB over AC. Okay? Well, instead of writing sides in proportion, I can rewrite that thing. So that's number 4. The last one, number 5. People, this is not so difficult, no? Even though most of the learners leaves it out when they do their paper 2 in grade 12. Many learners leave this out. But there isn't a reason for you to leave it out. Because it's simple, not so? And the only way you're going to be assured that you can do it is by doing this, the homework or the exercises. Okay? Don't tell yourself it's so easy, I can get it in the exam. I can figure it out in the exam. These are one of those topics that you can't figure out in the exam. You need the experience on it, okay? Experience working with the diagrams. Alright, exercise 4 on page 263, the last one. As I said before, these pages doesn't correspond with every textbook of this type. Okay, because there's many textbooks, there's many versions, and there's workbooks as well, okay? So if you have a workbook, of course it's not on page 263. The workbook is quite bulky or much bigger. Otherwise, if you get a thin workbook that they have, which is also a nice book, very thin, which have only the geometry. The thin book, I think like 50 odd pages. They sell it as well as at the bookshops. If you want, you can buy one of those as well. But we are told that AB is the diameter of a circle. So if AB is the diameter of the circle, what do we know? This is the diameter. What do we know? C2 is 90. Why? Angle is the semicircle. Not so. DC is a tangent at C. DC is a tangent at C. If there's a tangent, what do we know? C1 is equal to angle A. Why? Tango theorem. What else do we know? We also know that C3 is equal to B1 if needed. Tango theorem. Then we are told that BD is perpendicular to CD. Okay? So what can we say about these two triangles already? Those two triangles are similar. Why? Because we already have two angles that are the same, which is C1 and A, and C2 and C1 and A, and C2 and D, which is equal to 90 in that case. Not so. So automatically B1 is equal to B2. Why? Third angle of the triangle. Not so. The question says prove that that is the case. So how do we start off with similarity? So you go, they want angle B, D, C, and BCA. BCA. So yes, it is the two triangles we are speaking about today. Okay? You all okay with that? So let's go with that. Take it and that one. Oops. That's what we had, no? So we're going to say in triangle BDC and triangle BCA. Right, what can we say? We're going to say that angle C1 is equal to angle A. Why? Tango theorem. Not so. We're going to say that A2 is equal to angle D. Why? Wait. Remember at this point, the 90s wasn't in on the diagram, not so. So whatever is not on the diagram, we must state it. Okay. So firstly, C2 is equal to 90 degrees. Why? Angle in semicircle. Now I can put the 90. Then angle D, which is C, D, B, or just angle D is 90. Why is that 90? Because it's given. Given what? That BD is perpendicular to C. Okay. So therefore, C2 is equal to CDB which is equal to 90 degrees. Alright. Thirdly, we can say that B1 is equal to B2, and the reason there is the third angle of triangle. And absolutely enough information to conclude congruency. As you can see, B is equal to angle B, angle D, which is equal to angle C2, yes, and angle C is equal to angle A. So yes, it's in order. So I can conclude therefore, triangle BDC is similar to triangle BCA. As I also mentioned before, angle, that the order that is given to you will majority of the time be correct. Okay? If not all the time. Why? Because if you didn't manage to prove the similarity part, you can answer the next questions dealing with that given information. Okay? Right, again I'm going to take this off as to keep the diagram in focus. Okay? Ja, right skew, ne? That's it. Right. Let's look at B. In B we are told, right? What did we say? From a similarity question, they will always ask you a length question. Not so. So let's go with that. So before we go into anything, we say that BD over BC is equal to DC over CA equals BC over AB. Why? The proportionality theorem. No. What's wrong with you guys? Triangle BDC is similar to triangle BCA. As a. Right. Now we are told that AB is 25 centimeters. AC is 24. Calculate the length of BC. So let's plug in that information on this diagram, on this equation here. So AB is here at the bottom, is 25. Then we got AC is 24. Okay. They want you to work out BC. Okay, so if you look at BC, BC is there. Not so, but we don't have AD. BC, sorry. Okay? We don't have DC. So what does that mean? I can't then use this ratio. Because I must, for this ratio to work, I must have 3 known lengths and 1 unknown length. You can calculate the 1 unknown length. Not so. Or if it's the same length, then we need 2 known lengths and calculating the 1 unknown length, which is in both triangles. It's not going to work here. But if you're going to investigate where is BC, you see here's BC. So what do you notice? How can you work out BC? By using Pythagoras. Not so. They get off so long, definitely going to use it. So number one, the Pythagorean theorem. Okay, this is in triangle. You don't have to write this here. Just to highlight. Okay, it's in triangle ABC. In that triangle. According to Pythagoras, what is it? What's the theorem of Pythagoras? Who can remember? The hypotenuse squared is equal to the sum of your other two sides squared. Not so? It can only be done in right angle triangles. Is this a right angle triangle? Yes. So according to Pythagoras, it's going to be 25 squared is equal to CB squared plus 24 squared. The reason there, the Pythagorean or Pythagoras theorem with angle C2 equals 90 degrees. Okay. So CB works out to be 25 squared minus 24 squared equals the root thereof is going to give you 7. So that's going to give you 7 centimeters. Okay. You all okay with that? Any confusion? No? Number 2. Number 2, so just remember that one CD now. We have BC, which is 7. Okay, BC is in both ratios there. We know what AC is. AC is 24. We know what AB is 25. So it's definitely this ratio we're working with. Not so? You would agree? So it's going to be BC. No, DC, sorry. DC over 24 is equal to 7 over 25. Not so? So what do we do now? That's the matter of solving for DC. So you take it up. So it's going to be DC is equal to 7 times 24 over 25. Or if you want to cross multiply 25, DC is equal to 7 times 24. The same thing, and then getting DC on its own. Okay, put the multiplication in. So 7 times 24 over 25. It's going to give you 6,72. Let's check if that is correct. Yes, it is. Okay. Any confusion here? For those who did it homework. You all understand? Okay. People, again, it's a very, very important exercise to understand. Okay? As you can see, I did each and every sum because of the importance of the exercise. Okay? So now we're going to look at example 10. In this exercise, we're going to have to draw up our own triangles, which are similar. If we look at these triangles here, you'll see that, or these questions, you'll see that what is the first question? Prove similarity. Question 4a, prove similarity. 3a, prove similarity. You see that, people? However, here, in these examples that we're going to look at today, I don't know how much time I have left. In example 10, is 11 as well. So example 10, we're going to locate our own triangle in which we're going to work in. Okay? Right, we basically have 4 minutes left. So I'm just going to explain what's happening here. We'll probably do the same example tomorrow again, okay? Let's just take note of what's happening here. Then I'm going to give you homework from the Platinum textbook, dealing with proportionality only, okay? Otherwise you guys are going to go home without homework. And then for once, you're going to tell the truth when your parents ask. Don't you have homework? Then what do you say? As usual, what do you say? No. No? You might be telling the truth for once. So I must give you homework, okay? So before we move on, the homework is out of the Platinum textbook. We are not necessarily going to answer this tomorrow, but if you have time, you probably will. But like I said, there is this exercise we need to look at. From the Platinum textbook, I want you guys to do exercise 3 on page 226. Okay? The beginning of every lesson. If I don't answer it tomorrow, you just remind me the next time and the next time until we actually answer it. Okay? That will go in a different video. Okay? Sorry? It's in the Platinum textbook on page 226. Exercise 3. It's dealing with proportionality theorem. Okay? Okay. We haven't answered that the revision. We have 3 questions of the revision exercise that we still needed to answer. Not so? Out of the Platinum, the Mind Action series. Not so? Yes. You guys don't remind me.
Sir?
Yes. You can't remind me now.
No.
Oh, okay.
Where do we get from this guy?
I don't know. A very good question, huh? I don't know. But inshallah soon you'll get it back. Your test. No? People, this is on page 265. In page 265, example 10. We are told that circles A, B, C. So A, B, C, the circle here. And circle A, B, D, which is the smaller circle, intersect at A and B respectively. Intersect means to say the overlap or the cut, whatever. Are you right? Huh? Getting home? Okay. Then take your Joshua. Oh, you're getting cold, sir. Okay, nice. Were you in the sun during break? No. Okay. Second break, stay in the sun. You get home. Then we are told that AC is a tangent to circle ABD. So let's find circle ABD first. So ABD. So the circle here, AC is a tangent. If AC is a tangent, what do we know? Many things. What do we know? Yeah, clear your throat. So say, what do you want to say? What's clearing the throat? Who? Sheila. Oh, Sheila. Yes, go for it, my girl. Yes, AC is a tangent. So what can be concluded from that? A1, yes, is equal to angle T. Why? Tan cot. You guys got it? Right, nice. So I'm going to put a little dot here and the dot here, just to show that it's equal. Okay. Then AD is a tangent to the other circle. What can be concluded there?
A1 equals 2.
Not A1. A2. is equal to angle A2 is equal to angle CY. Tan angle theorem. Just looking at one glance, we can prove that that triangle is similar to that triangle. Tomorrow we'll talk about the order. Don't forget your homework, okay? I think part of the homework, let's leave the similarity of platinum for another day, okay? What I want you guys to do is the Euclidean geometry, the revision exercise here on page 216. On page 216, you conclude that revision exercse. Okay, because that's the when I do this textbook, there's a very important exercise. That's out of the platinum book. For that, I will make a different series of videos on that, on the platinum. All these is on the Mind Action series so far. Okay. People enjoy the rest of your day. Good morning, class.